Good afternoon, esteemed expert, faculty members of different institutes, colleagues, and dear parent participants. Myself, Dr. Joita Mujumdar, welcome you to day 2 of our faculty development program on innovation, entrepreneurship, and IPR. Yesterday, on day 1, we laid the foundation by exploring generative AI, opportunities, and framework on entrepreneurship oriented research. Today, we move into the agentic AI. For innovation, a shift from passive generative to proactive autonomous system. We are privileged to have Professor Dr. Animesh Datta sir with us, who will share insights on the topic. Professor Animesh Datta is a professor in the Department of Computer Science and Engineering at the National Institute of Technology, Durgapur, West Bengal, India. He holds a PhD from Jadavpur University in 2013 and has over 2 decades of research and teaching experience. His primary research interests encompass agentic AI and large language models, multi-agent systems, big data and social network analysis, and deep learning on graph analytics. Professor Datta has supervised 9 awarded PhD scholars and has 6 active ongoing doctoral research in agentic and network intelligence domains. He has published extensively in premier venues, including AAAI, IEEE transactions, expert systems with applications, and scientific reports. He has secured research funding from ACRB, DST, and Department of Electronics and Information Technology and holds 2 Indian patents. He has collaborated internationally with universities in France, Portugal, UK, and Italy, and is a recipient of the Vishwesvaraya Young Faculty Research Fellowship by Ministry of Electronics and Information Technology, Government of India, and ASEM Professor Fellowship in 2020 with Claude Bernard University, Lyon 1, France by European Union. So let's make today a highly interactive and impactful session with Dr. Animesh Datta sir. So sir, I welcome you to this FDP. So platform is yours. So no sir, not audible. Your speak mic is not.
Sorry. Is it audible?
Yes sir, yes sir.
And the screen is coming?
Yes sir.
Okay, thank you. So, the topic of my presentation is Agentic AI for Innovation, a shift from passive generative AI to proactive autonomous system. After the ChatGPT coin in November 2022, the release of their first version to the public, everyone is thinking about AI in different perspective. Okay. And many of us are using, most of us are using AI in their daily life. Now, so in and around, we are thinking of AI, we are using AI, we are doing some kind of research on AI. Now, the question is, what is the future of AI? Where we are going with this AI? So the intention of today's talk is to show some kind of futuristic idea where we are leading with this AI technology. So that's why it is not only from generative AI or LLM, rather we are moving from passive generative AI to proactive and autonomous system. And that is called an agentic AI. So this, the entire presentation is prepared by myself and my scholar, Suchishmita Sarkar, who is a full-time PhD scholar in this domain. So these are the today's agenda. It starts from agentic AI to key research area. I will be throwing some ideas where people can start doing their own research on this particular domain. That is my idea, because I heard from Sovik, many of you are faculty members either from Holdia or some other institute. So I will be opening up some research areas on this domain where people can start working on if you feel interest. So what is an AI? Is a very common definition. AI is a set of technique that mimic human capabilities. It is nothing unknown to anyone. Now, the current AI excels at a specific structured task, and future will focus on general unstructured tasks. So, if you see the timeline of AI, it starts in 1950s with a rule-based system, just in a very structured rule-based system, if then else, if this then this, if that this then that, like this way. Then in 1980s we have machine learning. So if you see from rule-based system to machine learning, in the rule-based system the human provide tasks, data, tools and approach, where machine provides execution. Now, similarly, if you go from rule-based to machine learning, the approach shifts from human provide to machine provide. Human only provide the task that it needs to be done, the data and the tools, and machine provide the approach and execution. So approach and execution does not need to be given by the human being. Now, from machine learning, if you go to the deep learning in the year around 2010, in the era of deep learning, you find that human provides only task and data. The tools also shifted from human provide to machine provide. So machine will provide the tools, approach and execution. Now in 2020, after the introduction of generative AI in the public, human provides task, the machine provides the entire thing, like the data. You don't need to put the data is already pre-trained. Machine has its own tool, machine has its own approach and execution. So the only thing that you need to give, you need to say what you want, the task. So that is the era of generative AI. Now, what is the next that we will be discussing today? So what are AI agents and agentic AI? And what is the motivation of that? The generative AI or LLM that are pre-trained and they are run on prompt basis. So this generative AI or LLM are trained with huge amount of data, mostly publicly available data, and on that data, if you ask some questions, it will answer only from those data. But if the data is not available, if your LLM system is not trained with the data, maybe there are some data which are secured for a particular company or secret that they don't want to disclose. So that data are not trained with the LLM system. So if you ask the queries on that LLM, which are not trained with those particular secret data of the company, it will simply hallucinate. That is the idea. Because the LLM is not trained with the particular data. For example, Haldia Institute of Technology, they have their own some kind of information system or kind of some order, some notifications. So these data are not trained any LLM. So if you ask these questions to LLM about the Haldia Institute of Technology and a particular order or a particular notification, it will simply hallucinate. So what is AI agent then? The AI agent is an LLM. Of course, the LLM or the generative AI. Along with that, it has a planning and tooling. So when we talk about AI agents, it not only have the LLM or generative AI, along with that, it will have a planning plus tooling. So what is AI agent? AI agent is a software system that perceives the environment and work for a certain goal. So whenever an AI agent works, it takes some input from the user or it perceives the environment. It has some goal to achieve. To achieve that goal, it will make some plan. It may need some tool that they will use, that agent will use and will perform the task to achieve that particular goal. So there are two approaches. One is the non-agentic workflow, one is the agentic workflow. In non-agentic workflow, if you see simple generative AI or LLM, which is not agentic. It is simple like a chatbot where you are asking a query and that it will process that query and it will simply respond. It doesn't have any kind of tool. How it will respond? It will respond only with the data which has been pre-trained. So you may have an LLM system like Llama or BART or GPT model that has been pre-trained with lot of data. If you are asking that particular data, it will simply answer. But if you go for agentic workflow, it has a user query. When that user query comes to the agentic workflow, it will make a plan. It will make a plan. It will execute some action. It reflects on the result of the actions. And there is a loop back of it. That means there is some kind of critic inside that what it is producing, whether it is acceptable or not. So this loop may continue for some times. And finally, it will return the result to the user or the environment. So one is the non-agentic workflow, another is the agentic workflow. During this agentic workflow, it may use some kind of tool like databases, some APIs, some other file system, or even some other agent also. So as per the planning, it may go for exploring the other required tools and APIs. That is for agentic workflow. So there is a difference between non-agentic workflow and the agentic workflow. Today's discussion is based on agentic workflow. So as I said, an AI agent is a collection of LLM. The core of the agent is the LLM part, the planning and the tooling. So user ask for a query like plan a trip from Seattle to Vancouver for 3 days with at least 2 attractions per day, provide accommodation that fit 3 people and a budget constraint of $300 per day. That is the user query. Now, once this query comes to an AI agent, the AI agent will find out what are the necessary tools that may require. So based on the user query, it will try to find out, it will decompose it into different sub-plan. Maybe it may look for the hotel accommodation, it may look for the attraction in that particular place, it will find out the hotel with a $300 per day, maximum $300. So a lot of things that it will plan. And based on that, it will respond. It may respond 1 option, 2 option, 3 option, 4th option. These are the possible options that may be given. So inside this, based on this request, it will make a constraint enumeration. What is a constraint? There are 3 people. They are ready to spend maximum $300 per day. Not more than two attraction in a day. So these are the constraint. So this is called constraint enumeration. So there can be in number of constraint, like the first constraint, daily budget should be up to $300. 3 days, 2 attraction. Okay, so these are the constraint. So this constraint will be checked what the agent is responding. So inside this, it is basically working as a critic that what agent is responding, whether that response is satisfying the constraint provided by the user or not. So this entire thing goes on in a kind of loop or feedback. And finally, an evaluation and synthesis is done and the evaluated result is provided. That is an example of an AI agent. So it is not simply an LLM, rather much more beyond the LLM, like planning, tooling, etc., etc. So if you have, please, I want this lecture should be very interactive. So if you have any queries, you may feel to ask in any moment of time. I'll be happy to do that. So, so it is an orchestration of LLM planning and tooling. It requests for a topic like research agent. It is asking. So it composes of several agents: researcher agent, writer agent, and publisher agent. So user gives a query that I needs this write up of a particular topic. So it will find out the research. The research agent will be responsible for finding a similar document like literature survey kind of thing. Then you have the writer agent. The writer agent will start writing. So see, this is an orchestration of LLM planning and tooling and composed of several such agents. So each agent composed of an LLM, the planning and tooling. And in the top of that, you can have a manager agent who is maintaining all the three agents. So it is a kind of something like the organization, the way an organization works. You have a head of the department in the computer science. Under head of the department, there are faculty members, there are non-teaching staff, there may be some group D people. So all together they form a department. They have their specific tasks to run the department. In a similar thing, it is happening like an organization. So I'm not going to the statistics part of it because there are a lot of slides. So I will be focusing mainly on the technical part of it. So motivation for agent design pattern. So as I said, an agent that composed of augmented LLM or augmented memory or LLM or generative AI and the memory. These are the three parts that needs to happen for an agent. So an user gives a query or an agent may perceive the environment. Based on the perception, it will make some kind of planning. So here, the LLM is working like the brain of the agent. LLM is working as a brain of the agent. So because LLM has the capability to understand user query, it has the capability to understand the environment, and based on that, it can identify what are the tools or memory module that I need to solve this task. That's why LLM is called the brain of the agent. So based on that planning, it will request for some tool which are not available within it. What can I use to help me? There may be some memory requirement. So it will use the memory. So based on this, so you have an LLM, you have a tool and the memory. So based on the user query or the perception of the environment, it will perform some action, and that action will be performed on the environment itself. So the action will be performed on the environment itself, and that will also perceive the agent again. So it is again a loop. It is happening continuously. Think of this. An AI agent that integrates generative AI, the LLM, the tool, and the data. So it perceives, user gives a query, it goes to the planning portion, that is the LLM part. It finds out what are the things that I needed. Maybe it is looking for something which is not available within this agent. So it may need some kind of web search. So it will go for searching the web. So this web search can be treated as the tool. So this AI agent needs some kind of information which is not available within the LLM. So it has to take it from web web search. So it will call the web search. It may need some kind of information about the prompt history. The prompt history is kept in the memory. Many of are using ChatGPT. So under the ChatGPT screen, under this in the bottom left corner, there is a portion that is written as memory update. Sometimes you may get this icon, memory update. So based on the prompt you are giving repeatedly, the memory of the ChatGPT or your session is getting updated. Okay, so the memory will be updated and it will perform an output to the user, and it can perceive and it can modify it. So the current ChatGPT system, it has the capability to take text, image, or even audio as an input. But based on that, it may ask for some kind of tool, or it may ask for some memory, which is the chat history of the person. Think of another example. Suppose here the system integrates generative AI tool and data. Here it is not, the perception is not from the user query, rather it is the lab vitals and imaging of a patient. Suppose a patient is monitored with an AI agent system. So the inputs are lab report, the vitals, the images. That is perceived. So that is being perception. So after the perception, you have again three: the core brain, that is the LLM of the agent, the tool, and the memory. So after this perception, it will make a plan based on this lab report, vitals, and imaging. It may need some kind of tools. Maybe it may ask for some kind of PubMed literature, which is a top journal and conferences of medical science. It may need some kind of image analysis tool, because the lab report is coming through image. So it may need some kind of image analysis tool. So the agent will call an image analysis tool, which is not available within the agent periphery. So it may need someone's extra help, like another image analysis. So based on this tool, and also it may have some kind of memory, the patient history, like the allergy and other medical history of the patient. So you have the tool, you have the memory, you have the planning, and based on that, it will perform some kind of action on the patient. So this is another example of AI agent. Now, there is a possibility that your system may hallucinate because of some papers may be excluded from PubMed, or the results that are coming from the PubMed or image analysis may not be correct. In the language of generative AI, we can call them as hallucination. So it provides some kind of erroneous result. So when you have a safety critical system or kind of human life, you cannot directly apply this action to the patient. So what you can do? So it may be a fatal error. So what you can do? You can keep an human being. That you can call it as a human in the loop. You have an AI system, you have an agentic system, but along with that, there is a person who is also working in this loop. So whatever the recommendation of the agent is doing for the patient, that recommendation is being also verified by a human being and human doctor. And after that, it is applied to the patient. So blindly, the recommendation of the action of the agent is not performed on the human life, because it is a kind of fatal error for a human body. Okay, so some of the survey of agent design pattern. So you are very much familiar with, all of you use ChatGPT or Claude or Gemini. So this is a very single agent interaction with the environment. You have an environment, it perceives the single agent, it performs an action. The example, agent that performs sentiment analysis on provided text. Advantage is trivial to implement, predictable, its prompts are engineered correctly. So you have a single agent like ChatGPT or Claude or Gemini. You are writing you are asking for some queries. It will check it and it will give the answer. Just a single prompt or single agent system. So what is the limitation? The limitation is it cannot handle multi-step tasks. If your queries have multiple, because it doesn't have the capability to plan. Limited adaptability to new tasks. So example prompt, you are a sentiment analysis agent. So this is the system prompt of this sentiment analysis agent. You are a sentiment analysis agent. Your task is to classify input text into one of the following categories: positive, expression satisfaction, optimism, approval; negative, expression dissatisfaction, frustration, disapproval; neutral, informative, factual, emotional, balance; mixed, containing both positive and negative sentiment. So always return your answer in the format sentiment, like positive, negative, neutral, mixed. So this can be a system prompt for a single agent pattern. Example, Lauren loves her camera. So this is your example input. So it perceives, single agent performs action on it, and the action is the positive. So this is your system prompt. This is the example input, and the output or the action performed by a single agent is positive. Now, if you go for chain of thought, instead of single agent, you may have the same agent is performing a chain of thought. Like example use case, step-by-step problem solving in math or logic task. Advantage, better handling of complex and multi-step tasks. Easier to debug or error analysis. Limitation, may be slower than direct answer generation. Requires careful prompt or agent design. What is that? I have 2 cows. Mary has 2 sheep. How many animals do we have? This is the user input. What will be the system prompt? The system prompt is you are an agentic chain of thought reasoner. You are an agentic chain of thought reasoner. Work in 4 phases. The system prompt will divide it to work in 4 phases: plan, solve, critique, and finalize. Always output the most appropriate phases and content. So this system prompt will come to this chain of thought agent, COT. It will provide an output. What will be the output? Call 1, the first call, plan, LLM input. The input of the LLM is task. I have 2 cows. Mary has 2 sheep. How many animals do we have? This is the input of this LLM input. As I said, it is a chain of thought. So the work is performed in multi steps. So the output is phase, plan. So this is the planning phase. The content is steps. Count cows, count sheep, add them. So as we are going for chain of thought, after the first step, the output is this. So input was this, the output is this. So this output will be going to the next step as an input. This output will be going to the next step as input. Count cows, count sheep, add them. See, count cows, count sheep, add them. Count cows, count sheep, add them. What was the task? Task was the same thing. I have 2 cows. Mary has 2 sheep. how many animals do we have. So the plan is now steps. So the output of the first step goes to the next step as the planning. Now what will be the output of this? Solve, content, result, cow 2, sheep 2, total 4, candidate 4. That is the LLM output. So you can have multiple call depending on the task you are asking, depending on the number of steps your task has or your chain of thought has, that many number of times the LLM will be called. It's a multi-step LLM call. And as for this particular case, there are 2 steps. So after the second call, the result is generated. That result will be passing to the critic. I have 2 cows. Mary has 2 sheep. How many animals do we have? Plan, count cows, count sheep, add them. Solve. Result to 4. Now, so this is my critic agent. So the output of the critic agent, finalize, answer 4, justification 2 plus 2, 4. So it's okay. So finally, final answer is 4. So this is the chain of thought. An agent decomposes a problem into a sequence of steps. Tool use agent. The next is tool agent. An agent that uses calculator API to solve math problem. Let us assume your LLM does not have the capability to calculate. I mean, the calculator of API is not there. So it has to call a tool or API, calculator API, which will add or subtract or any kind of calculation. So in the same way, like the single agent, it perceives the environment. Based on the perception, it will plan. And what are the tools it may require? That tool will be called, it may be web search tool, it may be API, whatever tool, or it can be a database also. So it will call that tool. After taking output from the tool, it will perform, send the result to the agent, and finally the action will be. So see, an agent that uses a calculator API to solve math problem. Advantage, enable more real world applications. Suppose if I ask an agent that what is the temperature of Haldia now? An LLM cannot give you the answer because LLM is only pre-trained with previous data. But I'm looking for the current temperature of Haldia. Sitting at Durgapura, I'm looking for the temperature of Haldia. So it has to call the API or weather API, which can give the temperature of Haldia. And then it will send back to the user. Okay, so enable more real world example, modular and extendable, new tools and new functionalities. Add as much tool you are using, as much as your functionalities will be increased. The limitation, require robust error handling for tool failure. If some tools are failed, then you must have some kind of robust error handling mechanism. You must have a security consideration when using external services. For example, you are looking for a tool, and unfortunately or fortunately, you may be giving your secret information like your credit card information or bank information, etc., or your password information. So you have to be very careful while you are asking for some external tool. System prompt. You are a tool of agent. Available tools are calculator API. This is the, so calculator API is post. This is the calculator API. You have to give the maths like expression. Weather API like this. So based on the perception, it will call the calculator API or it will call the weather API. And rules output is only on JSON file. If the question is math, call the calculator API. If the question is weather, call the weather API. When calling a tool, return the Python code as a string that can be executed with exec. If there you are passed a JSON with tool result, respond with the result. For example, C. User input. What is 5 plus 2? So this you can call it as a perception. Your agent is perceiving a request to perform 5 plus 2. So agent is perceiving this. What is the next step? The LLM output will be a Python code. Please note, LLM output will be a Python code. What is the Python code? Action call code, import queries, respond. It is a calculator API. The input of the calculator API is JSON equal to expression, as I said, math expression, so 8 plus 2. Print response.json. So when you are writing what is 8 plus 2 to an LLM agent, the LLM agent will take that as an input and will pass it to the LLM. The LLM will give an output. That output will be a Python code embedded within calculator API, because you are looking for a calculator operations or calculator service, calculator as a service API. So it is passing a Python code. That Python code has an embedded calculator API. So that API is taking 8 plus 2, this maths expression, as input and providing the output as print RESP response.json. So that is happening. Tool call API, the result is 10. So the tool return response, API response is this. So this is the fourth step. Pass the result to LLM. Task what is 8 plus 2? The tool result is result equal to. So an agent that leverages external tool or API to enhance its capability. Yeah. So the action is. Then you can have a memory and augmented retrieval, augmented pattern, where you are having a separate memory module. The agent may ask or may use that LLM model. Example, an agent that orders your favorite pizza. You have an agent, you are asking your agent, please order the favorite pizza. So the moment you are asking your agent that you order a favorite pizza, the agent must know what is your favorite pizza. You are not explicitly giving what is your favorite pizza. It must know that what is your favorite pizza, what taste or preferences. Along with that, it must know where you physically located. It must know the bank details or credit card informations. Otherwise, the agent cannot order. So all this information, all this personal information must be known to the agent to get the favorite pizza for you. Example, agent that reason about the next is React pattern. Sorry, the next one is the React pattern. So this is an advancement of chain of thought pattern. Chain of thought, multiple chain of thought. Here you can have reason pattern or React pattern, reason and act, which will come in an alternative way. Agent that reason about a question, queries a database, and then reason again. Advantage: supports complex multi-step tasks. Enable integration with external APIs and tools. Limitation: more complex agent design and state management. Require robust error handling and observation interpretation. May be slower due to iterative process. If you have a very complex task that requires number of reasoning and action, and each step it may require some kind of tool or APIs, then this React pattern is used. Next, you have human in the loop. As I said, for the medical that example, whatever result that is performing an React agent, it may not be directly given to the environment or the action. Sometimes it may cause a fatal error. So before performing the action on the environment, it may be passed through a human being or human expert. So the idea is human being and the agent will work together. A tool that extract missing, finding a clinical notes or schedule follow-ups. Advantage: ensure that all action taken by the system are validated. So a human being will validate this information, that whatever actions the agent is taking that are valid. Can be configured to bypass human verification when confidence is high. After the, if you design an agent which can learn from the environment, or if you can embed like a reinforcement learning kind of thing, that your agent is gradually learning over the time. So after you get the confidence that your agent can work confidently, then you may bypass the human being. So when combined with memories, enable agent to learn from its mistake. If you have a memory implementation, so the agent can also learn from the mistake. What is the limitation? If everything must be verified, system risks being redundant. The other thing, human can also make mistake. Should I take some questions? Shobik, are you there? Or should we wait for the last lab? Do you have any questions?
Sir, one question in the chat box. Some Orpita Chakraborty has sent the message.
Yeah.
That is there. He is currently research on emotion recognition in autistic children using deep learning. So would it be feasible to incorporate agentic AI into this work for the purpose of the recognition emotion from both audio and facial inputs?
See, agentic AI is a shift paradigm of, or the futuristic AI, and the coming era is of agentic AI. You find a very less people who are working. I mean, you are writing your own code like object functions. You don't need to do that. Now you have an agentic programming. You can just simply create your agent will do everything. Okay, so whatever field you are doing research, I mean, with 100% efficiency, you can use agentic AI. There is no doubt about it. Okay.
So again, Orpita Chakraborty has written. So for this topic, should incorporate two agent. Yeah, sure. Hello, Orpita Chakraborty. You can directly call, ask the
Yeah.
question.
So that's what I'm asking. Happy to answer. Yeah, you'll be
Miss
happy to
Orpita
read.
Chakraborty, you can kindly directly call. Oh, acha. Yeah, she is traveling, sir.
Okay,
So
no
that's
issue.
why he is in the chat. So he's written. For this topic, should incorporate two agents.
This topic incorporate agents.
Urpita Chakraborty, kindly clarify the question. Sir, another question comes from Mr. Saurabh Bhomik. How the generative AI will put the impact on student IQ level?
It depends on how you use it. Okay. Uh, I have created an AI agent which is an expert physics, JE physics teacher. Okay. Now, I can ask that AI agent to generate 20 questions of JE physics in just 1 minute. I can easily give it to my son or daughter for practicing. It depends on how you use it. Okay, it is not the question of your IQ will be no more IQ for the student, or the intelligence will be gone. It's not the thing. The situation has come that you can be more advantageous with generative AI or using AI tool. For a school student, even you can generate a lot of questions for practice. Today, a remotely located school student does not need to go to a city for having a good teacher. There are a lot of AI tools which can, I mean, without any tiredness, will elaborate or make you understand a particular topic. That advantage can be taken by any student located in any part of the country. So that is, I think that is an advantageous.
Okay, sir. I hope Saurabh Bhomik, sir, you understand. So another question, sir, comes
Yes, ma'am.
from Shivananda Vishwas. So how can reinforcement learning based creative agents dynamically adapt artistic styles in response to audience emotional feedback in real time?
I I'm not
Sir, can I
about
repeat?
autistic or that type of technology, autistic kind of disease, or. But the thing is, you can incorporate. I mean, there is a hot topic which is called reinforcement learning for AI agent. Okay, so you may have a number of agent for a particular system. That agent will learn from the environment. So there are a lot of research going on where there is a combination of agentic AI with reinforcement learning. Okay, so you can easily incorporate reinforcement learning in agent.
Okay, Shivananda Vishwas, sir, I hope you understand what's that tale. So any more questions? You can directly switch on your mic and
Yeah,
directly
please.
call, ask the question to sir. Please switch on your mic and you can directly.
Okay, then you have agent orchestration pattern. An orchestration coordinates multiple agents, including the role assignment and communications. You can bring the same analogy, like you have to organize some program in the department or the institute, and for that you may deploy multiple student or multiple faculty members to do each of the tasks, and above that someone is there who is managing the entire workforce. In a similar way, you have an orchestration agent. That agent has multiple sub-agent, like agent 1, agent 2, agent 3, like that. Even you can have a human being also. So where agent and human being working collaboratively, and someone is monitoring the entire system. That is called agent orchestration. And orchestration coordinate multiple agents, including role assignment and communications. A manager agent delegates subtasks to specialized worker agent. So depending on the task or depending on the perception, a planning agent will divide into a multiple task. And each task will be assigned to a specialized agent. You have n number of agents, so you are assigning those tasks to different specialized agent. What is the advantage? Advantage is efficient handling of complex multi-step tasks. Enables parallelization and specialization. Scalable and modular system design. So you can achieve parallelization, you can expect specialization also. What is the limitation? It requires robust coordination and error handling, because I may have multiple agents, you may have multiple agents. This agent-to-agent communication is also one of the part. So while communicating some agent from me on behalf of me with you people, so there is a necessity of some kind of safety security. I have to be cautious about whether my agent is disclosing some secret information to other agent or not. So this communication and state management, that's a very important issue while coordinating multiple agents. Then you have planning of agent. Planning agent, this agent breaks down the task into smaller steps. You give a prompt, user gives a prompt, that prompt goes to an agent or planning agent. That planning agent divides the task into multiple subtasks and assign those tasks to multiple agents. Each agent is specialized for a particular task. If you take an example like you are going for a vacation trip with your family to somewhere. Now there is an agent who is responsible for making this trip. Now he alone cannot do everything. He needs to coordinate with hotel agent for booking the hotel. He needs to coordinate with the flight agent to book the flight. He may needs to coordinate with the local taxi agent who will arrange the taxi. So everything needs to be coordinated, and there are some specialized agent who is responsible for each of the separate tasks. So that's why you need planning. So it generates plans, given prompt, it evaluates the plan and execute the best plan with the best possible agent you have. Then tool use, as I already told, that when a user gives a prompt, based on this prompt, it divides into multiple tasks. That task, some tasks may need some kind of tool. For example, if it is a task of calculation, it will require an calculator API. If it requires weather of a particular locations, so it must go for weather API. Or it may need some kind of databases, some database information, so it will call the database. So you need to define the tools, what tools you have, LLM decision, function call, tool execution, and LLM processing. Then you have the last part is a multi-agent collaboration. This can be hierarchical collaboration, like you decompose the problem, delegate the task to multiple agents, exchange data, and synthesize the result. So user gives a task to a multi-agent team. Now this is a supervisory agent, It divides the task to multiple specialists. Then again, this specialist may also divide the task into two sub-specialists. So a complex query might be decomposed and assigned to a research agent for information retrieval, a data analysis agent for statistical processing, and synthesizes agent for generating the final report. The efficacy of such a system is dependent on the mechanism for inter-agent communication. Okay. Similarly, you can have this type of kind of architecture also. Like you have a network, you can have network of agent, you can have supervisory based agent, supervisory and sub agent, you can have hierarchical agent, you can have custom agent. So depending on the requirement, depending on the task, you can make the topology. You can have network of agent, you can have supervisory based agent, hierarchical based agent, and custom agent. Now, this is very interesting for the people who may be interested to work on this particular domain. Like, what are the key research area where you can start working? So the first area is coordination and collaboration. You may have a multiple agent. So the days are coming where one organization will have multiple agents. Similarly, the other organization will have multiple agents. So agent to agent communication, agent to agent collaboration and coordination will be an important issue. So the research will be on task allocation among the agents, conflict resolution and negotiation, emergent system behavior. Then the second is planning and decision making. You have a goal. That goal needs to be decomposed across agents. Distributed planning strategies, dynamic adaptation, and changes. Learning in multi-agent system. Someone asked the question, reinforcement learning. So here that comes. How each of these agents will learn on runtime. Then you have agent-to-agent communications. As I will have some agent in future, you people will be having some agent. So we don't need to communicate with each other, rather our agent will communicate on behalf of us. So while communicating my agent with your agent, then what inter-agent protocol needs to be designed? Natural language versus structured messaging, shared understanding and context. So that will be another issue. Then tool use and environment interaction, as I said already, that while you are calling an agent, that agent needs some kind of specialized tool. That tool may be an API, maybe some databases. So tool use and environment interaction, that can be another research area. Memory and knowledge sharing. How will you update the memory? How will you optimize the memory? That is another issue for the case of multi-agent system. Safety and alignment control, preventive uninterrupted behavior, multi-agent alignment strategy, monitoring and governance. As the future are coming with the multiple agents, so who will monitor those agents, whether they are working properly or not? Where will be the governance of those agents? Then, as I said, there are some safety critical tasks where you cannot put entire agent system in the work. There may be some human in the loop. In that case, human agent collaboration is another issue. That how much task will be given to the agent, what amount of task will be with the human being. Then scalability and infrastructure, that is another issue. Evaluation and benchmarking, economics and strategic behavior, and domain-specific application like healthcare, finance, robotics, autonomous system, enterprise, AI workflow. So specific application-based multi-agent system design. So these are the key areas where people can start working. If you want to think about your PhD or research or postdoc, you can choose any of the area. All the topics are very hot topic nowadays. Then some of the pros and cons for using AI. High autonomy, increased productivity. You can assign some of the tasks to the agent. So instead of doing by yourself, you can assign the task to the agent. So that will increase the productivity. Better decision making. Scalability. Handles large tasks and adapts to growing needs. Continuous learning. As I said, you can incorporate reinforcement learning inside the agent. So on runtime, the agent can learn from the environment. So Just like the human being, over the experience we learn, in the similar way, the agent will learn over the time. What are the cons? Unpredictable behavior, may act in unexpected ways, especially in complex scenarios. That taken care who is designing the agent or multi-agent system, you have to be very careful about their behavior. Security and risk, vulnerable to attack, misuse, and unauthorized action. Lack of transparency. When you are delegating some tasks to your agent, the things are not transparent. How they are performing, what they are performing, at the end you are getting the result. So the transparency is one of the issues while you are using multi-agent system. Ethical and bias concerned, it depends what type of data you are feeding with your LLM agent. Accordingly, it may be biased. For example, if you ask an agent to provide the picture of a nurse, it will definitely put a picture of a lady nurse. But there can be a man as a nurse. Similarly, if you ask to draw a picture of a police officer, it will always give a male police officer. But there are a lot of female police officers. High complexity and cost, needs quality data, compute, monitoring, and skill team. So these are the cons, the challenges of using agentic system. So the future is of collective intelligence, where human and AI will be working together. So that is the future. Today or tomorrow you have to adapt it. Just only having the generative AI will not serve your entire purpose. You have to use agentic technology. So agentic technology is the next of AI, where human and AI agent will work together collectively for a common goal. So these are the references from where we have started our slides and all. And some of my PhDs who have completed the PhD thesis on this domain. So already four have already completed their PhD in this domain in multi-agent system. One is ongoing. Okay, thank you so much. If you have any questions, you can ask, or you can take my mobile and WhatsApp number for queries, any research ideas. I'll be happy to discuss. We can have a meeting.
Thank you, sir. So if you have any queries, just switch on your microphone and ask. So, sir, I think there is no question from that
Okay.
the participant.
That is the most boring part of online FDP. Okay. Okay.
So,
I'm not very much accustomed with this online performance.
Sir, we have successfully then reached the conclusion of the day two. So, it is a very good session and the day of profound insights into the agentic AI for innovation. So, on behalf of the organizing committee, I would like to express my gratitude to Professor Dr. Onimesh Dr. Sir for sharing his expertise so generously today. And I also thank each of you, all the participants, for your active participation, for making the session so dynamic. So, sir, on behalf of the organizing committee, the some appreciation from our side. So that's the certificate for you. We will send you the certificate through the mail, through your mail.
Okay. Thank you. Thank you so
Thank you,
much.
sir. Uh, Thank you, sir. Uh,
Okay, thank you. Thank you so much.
so so we will end at the today's session. So please ensure all the participant you have submitted your feedback forms for the today's session, and we have also an equally enriching agenda planned for tomorrow. So please join at the time 4 p.m. tomorrow. Thank you. The feedback link is shared in the message box. So it will submitted within 6 p.m. today. Okay.